This is CD4Peace.
Scientists at Scripps Institution of Oceanography at the UC San Diego used an unprecedented technique to deter that levels of helium are rising in the atmosphere, resolving an issue that has lingered among atmospheric chemists for decades. The atmospheric abundance of the 4-helium 4He isotope is rising because 4He is released during the burning and extraction of fossil fuels. The researchers report that it is increasingly at a small, but for the first time, clearly measurable rate. The 4He isotope itself does not add to the greenhouse effect that is making the planet warmer, but measures of it could serve as indirect markers of fossil fuel use. This is Samantha, and welcome to the 4 Minutes for Peace podcast series. In this episode, we will be delving into another aspect of what we work here at CD4Peace, which is sustainable development. Stay tuned to know more about our rising helium levels. The National Science Foundation supported study was published on the 6th of May in the journal Nature Geoscience. The main motivation was to resolve a long-standing controversy in the science community about atmospheric helium concentration, said study lead author Benny Berner, a former graduate and now postdoctoral researcher at Scripps Institution of Oceanography at UC San Diego. The isotope 4He is produced by radioactive decay in the Earth's crust and accumulates in the same reservoirs as fossil fuels, in particular those of natural gas. During the extraction and combustion of fossil fuels, 4He is coincidentally released, which creates another means to evaluate the scale of industrial activity. The study's breakthrough is in the technique the Scripps Oceanography team used to measure how much helium is in the atmosphere. Berner and Scripps geoscientists Jeff Sevringhaus, Bill Poplawski, and Ralph Keeling created a precise method to compare the 4He isotope to levels of the common atmospheric gas nitrogen, because nitrogen levels in the atmosphere are constant. An increase in the He/N2 is indicative of the rate of He buildup in the atmosphere. The study's breakthrough is in the technique the Scripps Oceanography team used to measure how much helium is in the atmosphere. Berner and Scripps scientists Jeff Sevringhaus, Bill Poplawski, and Ralph Keeling created a precise method to compare the 4He isotope to levels of the common atmospheric gas nitrogen. Because nitrogen levels in the atmosphere are constant, an increase in He/N2 is indicative of the rate of 4He buildup in the atmosphere. Study co-author and Scripps Oceanography geochemist Ralph Keeling, overseer of the famed carbon dioxide measurement known as the Keeling curve, describes the study as a masterpiece of fundamental geochemistry. Though helium is relatively easy for scientists to detect in air samples, present at levels of 5 parts per million of air, no one had done the work to measure it carefully enough to observe an atmospheric increase, he said. The study also provides a foundation for scientists to better understand the valuable 3-helium 3He isotope, which has uses for nuclear fusion, cryogenics, and other applications. Proposals to acquire the scarce gas from the moon are an indication of the lengths to which manufacturers will go to harvest it. According to previous work by other researchers, the 4He isotope exists in the atmosphere in what appears to be an unvarying ratio with the 3He. The atmospheric rise of the 4He isotope measured at Scripps, therefore, implies that the 3He isotope must be rising at a comparable rate as 4He. The research by Berner's team raises several questions about the accuracy of scientists' previous assumption about how 3He is produced and in what quantity. We don't know for sure, but I wonder if there is more 3He coming out of the Earth than we previously thought, which could perhaps be harvested in fewer nuclear fusion reactors in the future, Berner said. The study lays in the starker relief a controversy surrounding the rare helium isotope 3He, said Keeling. While the current implications of this phenomenon are far from clear, it begs additional work as it could have a severe impact on the air that we breathe and are exposed to.
4 Minutes for Peace, podcast produced by CD4Peace, Cultural Diversity and Sustainable Development for Peace, organization established in Geneva since 2018.